will discuss that what is petrography, what is difference between the petrography and petrology, what is the importance or significance of petrography, how texture differs from the structure, and what is igneous petrography and what is igneous rocks, what are the types of igneous rocks and how they form. First we discuss petrology. Petro means rocks, while logi means study. So simply petrology refers to study of rocks. Study of rocks and their formation is termed as petrology. We may define petrology as a science dealing with the composition, texture and structure of rocks, their occurrence and distribution, and their origin in relation to physico-chemical conditions and geological processes. It means that in petrology, we not only study about the composition, texture and structure of any rock, but we also study about their occurrence and distribution, that where that particular rock is found, where it is present within the earth or on the earth, and what is the origin of that rock, how it has been formed, and what were the various physico-chemical conditions at the time of formation, and how various geological processes have affected the formation of that particular rock. So, petrology is the detailed study of rocks covering its various aspects, ranging from the texture and composition to its origin and distribution. We may rightly say that petrology includes both petrogenesis and petrography. While petrogenesis refers to the formation of rock, it refers to the process of formation of any particular rock, while petrography refers to the detailed study of any rock on the basis of its mineralogical composition and textural features. So, we are right to say that in petrology we study both the petrogenesis as well as petrography of rocks. Now, what is petrography? It is study of rocks in thin section based on optical properties of constituent mineral grains by means of petrographic microscope. Petrography is a branch of petrology that focuses on detailed scientific descriptions and classification of rocks. Now, what is petrography? First is that it is branch of petrology, and in this branch of petrology we study the rock in detail usually within thin section on the basis of optical properties of mineral grains present within that rock, and this study is usually carried out with the help of petrographic microscope. So in petrography, usually thin section of rock is studied and the mineralogical composition and structural features present within that rock is analyzed, or it is focused with the help of petrographic microscope. And on the basis of this description of the mineralogical and textural features of any rock, then that rock is classified. So it is, we may say that it is detailed scientific description or study and classification of rocks. Now, what is importance or scope of petrography? In petrography, the mineral content and textural relationships within the rock are described in detail. The classification of rocks is based on the information acquired during the petrographic analysis. The detailed analysis of minerals by optical mineralogy in thin section and macro texture and structure are critical to understanding the origin of rock. In these three lines, scope of petrography is described. In petrography, we not only get information about the mineralogical composition and textural features of rocks, but we can use that information about the mineralogical composition and textural features of rock for the classification of that rock, that to which category the rock under study belongs. So, petrography is essential for the classification or identification of any particular rock, and this classification or identification is carried out by mineralogical composition and textural features of that rock. And these mineralogical composition and textural features of rock is derived or deduced on the basis of petrographic analysis, which is usually carried in thin section with the help of petrographic microscope. Second importance of petrography is that without detailed information about the mineralogical composition, texture, macro texture and macro structure of any rock, we can't understand the origin or the process of formation of that rock. So the study of mineralogical composition, macro texture and structure of any rock on the basis of optical properties is essential for the understanding of the origin of rock. It is essential for understanding the formation of rock. So, we may rightly say that it is prerequisite to the petrology. Without petrography, we can't understand the petrology of rocks. It is first step towards the petrology. While optical mineralogy is step or it is prerequisite to understanding of the petrography. Without optical mineralogy, we can't understand the petrography of any rock, because petrographic analysis usually based or it is usually carried out on the basis of optical properties of minerals, while petrography is then essential for understanding of petrology, because without petrographic details or petrographic analysis of any rock, we can't understand the process of formation of that particular rock. So, it is prerequisite to the petrology, and petrology can be igneous petrology, it can be metamorphic or sedimentary petrology, which depends upon the rock under the observation. Now, it has also scope or importance in the petroleum geology. In petroleum geology, the source rock evaluation is based on the petrographic analysis or petrographic study of the organic matter or corrosion present within the source rock. Moreover, petrographic analysis is also essential for understanding the various parameters of reservoir rock, and reservoir rock refers to that rock which contains petroleum in commercial amount. With the help of petrography, we not only understand the permeability and porosity of reservoir rock, but we also understand the interrelationship between the pores, mineral grains and the matrix. So, it is important or it has significant role in the petroleum geology. What is the role of petrography in engineering geology? Remember that engineering properties of rocks depend upon the engineering properties of any rock depend upon its mineralogical composition as well as its textural features. By engineering properties, we mean that how any particular rock will behave when it is used for any construction purpose. And the strength of rock depends upon the mineralogical composition and textural features. And we know about the mineralogical composition and textural features of any particular rock with the help of petrography. So without petrographic analysis, we can't deduce or we can't understand the strength of any rock which is going to be used for construction purpose. So petrography has its due role in the engineering geology, economic geology. As you know that economic minerals are present usually within the rocks. So first, petrography is essential for identifying or identification of economic minerals present within the rock. Moreover, it is also important for the quantitative analysis of economic minerals present within the rock. It means that it is essential for knowing that how much economic minerals are present within any particular rock. Tectonics. What is role of petrography in tectonics? Remember that tectonics not only affect the rocks on larger scale, but tectonics also affect the mineral grains and the textural relationship or the textural features of any rock when it is exposed to the tectonic stresses. So any rock that has undergone tectonic stresses, which has been exposed to the tectonic stresses, will have different textural features than that rock which has not undergone through the tectonic stresses, which is not exposed to the tectonic stresses. So petrographic analysis of any rock help us in understanding the tectonic history of any particular rock, as a rock which has been exposed to the tectonic stresses or which has been passed through any tectonic process will have different mineralogical composition, and especially it will have different textural features than that rock which is not exposed to the which has not been exposed to the tectonic stresses. So petrography help us in understanding the tectonic history of any particular rock. And these are the few of the various importances or significance of petrography. Who was father of petrography? Usually Karl Heinrich Ferdinand Rosenbusch is termed as father of petrography. He is also known as Harry Rosenbusch. Harry Rosenbusch is considered as the father of petrography. He was a German geologist who laid the foundations of petrography. He was born on 24 June of 1836 in Anbeck, while he died on 20 January of 1914 in Heidelberg of Germany. Now, what is difference between the texture and structure? The first difference is the scale. Texture are smaller features. They are inherently small-scale aspects or features of rocks, most easily recognized in hand specimen or thin section. On the other hand, structures are large-scale features easily recognized in the fields in outcrops like layering, jointing, and delineation. Texture are small-scale features. Usually they are identified or they are recognized in hand specimen or in thin section. On the other hand, structure refers to the large-scale features of rocks which are usually visible or recognizable in the field or in the outcrops. Texture describes the size, shape, and the spatial orientation or spatial arrangement of the grains constituting a rock, as well as the relationship between the grains. Textures tells us about the individual grain size, their shapes, their arrangement, as well as their interrelationship. On the other hand, structures provide information about magma movement or flow, movement of crystals within magma movement or within the magma flow. They tells about the large scale movement of the magma, as well as structure tells us about the crystal movement within the magma flow. Examples of structures include the layering, roofy surface of lava, lineation, foliation, pillow structures, gianting, etc. Now, what is igneous petrography, metamorphic petrography, and sedimentary petrography? You people know that rocks are primarily categorized into three categories or into three classes, that is igneous rocks, metamorphic rocks, and sedimentary rocks. In the same way, petrography is then divided into three sub-branches or sub-disciplines. One is igneous petrography, which deals with the igneous rocks, while metamorphic petrology, and sedimentary petrology deals with the metamorphic rocks and sedimentary rocks respectively. We will first focus igneous petrography, but before going to discuss igneous petrography in detail, first we discuss the igneous rocks. What are the igneous rocks? Igneous rocks refer to those rocks which have been formed by the cooling or solidification of magma or lava. They have been solidified or they have been formed by the solidification of magma or lava on or below the earth's surface. Now, what is the difference between the magma and lava? Magma refers to the molten rock, and the molten rock material present within the surface is termed as magma, while lava, on the other hand, lava refers to the magma present on the earth's surface. We may simply say that lava is the magma on the surface. Magma is present in the subsurface, while lava refers to the magma present on the surface. What is the various classification system of igneous rocks? Igneous rocks, first category of igneous rock is volcanic or extrusive rock. What are volcanic or extrusive rock? Volcanic or extrusive rock refers to those igneous rocks which have been formed by the solidification of lava. They are formed as a result of cooling or solidification of lava. When the magma or lava erupts to the surface, then the cooling lava results in the formation of volcanic or extrusive rocks. Examples of extrusive rocks include basalt, andesite, rhyolite, and comatite. What are the intrusive or plutonic rocks? These are those igneous rocks which are formed by the solidification of magma, and you know that magma refers to the molten rock present within the earth's surface. So they have been formed by the solidification of magma in the subsurface. Examples of intrusive or plutonic rocks include granite, gabbro, diorite, and peridotite. What are the intermediate or hypabasal rocks? They are also called as subvolcanic rocks. The intermediate or hypabasal rocks form at the depth in between the volcanic and plutonic rocks. They are they formed at medium shallow depth. They form at the depth in between or intermediate between the extrusive and intrusive rocks. They are neither formed by the deep-seated plutonic bodies nor they form from the superficial or the lava present on the surface of Earth. They are called as subvolcanic because they form at the depth below the volcanic rocks. And the intermediate or hypabasal rocks usually exist or they occur in the form of sills and dikes. Example of intermediate or hypabasal or subvolcanic rock include dolerite. Dolerite is one of the hypabasal rocks. Classification of igneous rocks on the basis of texture. Aphanetic or fine-grained igneous rocks. These are those rocks in which individual mineral grains are not visible to the naked eyes, and we take help from the petrographic microscope for study of aphanetic are a fine-grained rock. Another end, phaneretic are coarse-grained rocks refer to those rocks. They are those igneous rocks in which individual mineral grains are visible to our eyes without the help of petrographic microscope. Now, what are the hyaline or glassy rocks? What are the hyaline or glassy rocks? These rocks, these are the igneous rocks which contains glass. They are composed of glassy material. There are no crystals formed. There are no crystals found within these rocks. They are formed by the rapid cooling of the lava or of the magma. So they don't have any crystals. Now, how igneous rocks are classified on the basis of chemistry or chemical composition. First category of igneous rocks on the basis of chemical composition is felsic or silicic rocks. The term felsic is combination of two words. One is fel, which refers to the iron, while sic refers to the silica. So these are the silica rich rocks. They have silica more than 65% or 66%. Common minerals present within the felsic or silicic rocks include plagioclase feldspar, alkali feldspar, quartz, and sometimes muscovite. Example of felsic or silicic rocks include granite and rhyolite. Now, what are mafic rocks? The term mafic is again combination of two terms. Ma is for magnesium and fic for the iron. So these are the magnesium and rich rocks. They contain 35 to 52% of silica, while the common minerals present within the mafic rocks include the olivine, pyroxene, hornblende, and biotite. Hornblende is a type of amphibole mineral group. Examples of mafic rocks include gabbro and basalt, while the intermediate rocks have chemical composition in between the felsic and mafic rocks. They have 52 to 66% of silica. They have equal portions of mafic and felsic rocks. Intermediate rocks have equal amount of mafic and felsic minerals. The examples of intermediate rocks are diorite and andesite. While what are the ultramafic rocks? They have almost entirely ferromagnesium minerals. And they contain no quartz or feldspar. They have less than 45% of silica. Examples of ultramafic rocks include peridotite and comatiite. This is diagram which elaborates the mineralogical composition of various rocks. This field includes the granite and rhyolite, which are felsic or silicic rocks. Granite is intrusive, while rhyolite is the extrusive equivalent of granite. These felsic rocks contain K feldspar, which is also called as alkali feldspar, quartz, and albite, whereas albite is sodium-rich plagioclase. It is sodium plagioclase, and it may contain the mica. Mica can be biotite or it can be sometimes muscovite. On the other hand, intermediate rocks have quartz as well as plagioclase feldspar, as well as it have mafic minerals such as amphibole and pyroxene, as they contain both the mafic and felsic minerals. And the examples of intermediate rocks are diorite and andesite. Diorite is extrusive equivalent of andesite. What are the chemical composition of mafic rocks? The mafic rocks contain anorthite, which is calcic plagioclase or calcic feldspar, while it contains amphibole, and it also contains pyroxene and some amount of olivine. On the other hand, ultramafic contain entirely olivine and the pyroxene. There are no felsic minerals present within the ultramafic rock. Examples of ultramafic rock include peridotite and comatiite. Comatiite is extrusive equivalent of peridotite. In this diagram, various classification system which we discussed is given in more concise form. These are the minerals. The second line includes dominant minerals, while this row includes the accessory minerals present within the rock. These are examples of various rocks. This is textural classification of igneous rock. Pheneritic or coarse grained rock in which grains are visible to the naked eyes. In aphanetic, no grains are visible. An example of pheneritic rocks include granite, diorite, gabbro, and peridotite, while aphanetic rocks include rhyolite, andesite, basalt, and comatite. And remember that these rocks are also extrusive or volcanic rocks. So we may rightly say that volcanic rocks are usually aphanetic. On the other hand, plutonic or intrusive rocks are pheneritic usually. They are coarse grained. Porphyritic rocks, porphyritic texture refers to that texture in which large grains are embedded or large grains are present within the small grains. Large grains are surrounded by the small size grains. Glassy texture refers to that contains no crystal and is composed of entirely glass. Pyroclastic texture refers to that texture in which fragments which have been formed from the fragments is also called as fragmental texture. Obsidian and pumice is example of glassy texture. These rocks possesses glassy texture, while tuff and volcanic breccia contains they have pyroclastic texture. They are usually formed by the solidification of fragments. Rock color. Rock color depends upon the presence of dark minerals. This classification on the basis of rock color is old one. Usually, in initial days, the rocks were generally classified on the basis of color, as the felsic rocks usually have light color, another and mafic have dark color. The color of rock depends upon the presence of dark mineral. More the dark minerals, more the color will be darker. As here you can observe that rock with 0 to 25% of dark minerals possesses light color, and dark minerals are usually mafic minerals. On the other hand, those with the 85 to 100% of mafic minerals or dark minerals possess dark color, or they are almost entirely black. These are the ultramafic rocks which are usually black. These are the mafic rocks which are dark but less dark as compared to the ultramafic. Intermediate are neither dark nor light in color. They have color in between the mafic and felsic rock, just like its composition which is in between the felsic and mafic rocks. These are the felsic rocks. As you extend it towards the top, then this field lies within the felsic rocks. Felsic rocks usually have 0 to 25% of dark mineral. This was all about today's class.